In this video, I will show you how to evaluate a definite integral like these ones, given a graph like this one. Look at part A. We need to evaluate the integral of function g from 0 to 2. This means the area between function g and the x-axis between an x value of 0 and an x value of 2. This is the area between g and the x-axis from 0 to 2. Because this area is above the x-axis, it will be considered a positive area. There are many ways to calculate this yellow area, but here's the one that is jumping out at me. We could find the yellow area by first finding the area of the large red triangle and then subtracting the area of the small white triangle. So my strategy is big triangle minus small triangle. The area of a triangle is 1/2 base times height. For the big triangle, that is 1/2 3, the base is 3, so 1/2 3 times 2, the height is 2. For the small triangle, we have 1/2, the base is 1 and the height is 1. Well, 3 times 2 is 6, and half of 6 is 3. And this is simply 1/2. So I have 3 minus 1/2, which equals 2.5. So that would be the yellow area. Some students are not comfortable with the subtraction method that I just did, where I did the large triangle minus the small triangle. So I'm going to quickly show you another method that you could use to find this yellow area with only addition. For this strategy, I will divide the yellow area up into 3 shapes with which I am familiar. Then we can just add up the 3 areas. So I'm going to do triangle plus square plus triangle. For the first triangle, I'm doing 1/2 base times height. So that's 1/2 1 times 1. And then the square is just base times height, so that's 1 times 1. And then the second triangle, 1/2 base times height, is 1/2 1 times 2. So this first term is just going to be 1/2. And then the second term is 1. And the third term is 1. Half of 2 is 1. And if you add all of these up, you get 2.5, which is the same thing that we got by the subtraction method. Take a look at part B. Notice that part B is the same as part A, except the limits of integration have been reversed. Instead of evaluating the integral from 0 to 2, now we are evaluating from 2 to 0. When you reverse the limits of integration, you change the signs. So you could think of it as if you're going from right to left on the x-axis, all right, because this is from 2 to 0, so we're sort of going backwards. That's going to be a negative answer. So I don't need to do this all over again. I just need to know that it's going to be the opposite of the integral from 0 to 2 of g of x. So since the integral from 0 to 2 was 2.5, this answer will be negative 2.5. For part C, we need to evaluate the integral from 3 to 7. The integral of g of x from 3 to 7 is the area between g and the x-axis from an x value of 3 to an x value of 7, shown here in blue. Because the area is below the x-axis, then it will be considered a negative area. But how do we calculate the area of a shape like this? We don't have any formulas memorized for this sort of crescent type of a shape. So what do? We can again view this as a subtraction problem. If we take the area of the large rectangle, and then subtract the area of the semicircle, that will leave the blue area that we want. So we're doing rectangle minus semicircle. The area of a rectangle is base times height. The base is 4 units, and the height is 2 units. So this is the area of the rectangle. Let's subtract the area of the semicircle. So the area of a circle is pi r squared. The radius is like this. Okay, I could look at the radius as going from here to here. So the radius is 2. So we have pi 2 squared. This would be the area of a full circle. Because this is a semicircle, I will do half of this. So keep in the back of your mind that at the end I'm going to have to stick a negative sign onto this because it is below the x-axis. Right now I'm just finding the straight area, but ultimately it needs to be negative. So what can I do? I think I'll go ahead and write 8 minus 2 squared is 4. Half of 4 is 2. So I have 8 minus 2 pi. Now is probably as good a time as any to slap a big old minus in front of all this, because this has to be a negative area. So I'm just going to put a negative in front of all of this. Maybe I'll put it even in front of my pictures. All right, because it is below the x-axis, the area must be negative. So same here. So there's not a lot I can do with this. So I can just leave my answer like this. Negative, and then the quantity 8 minus 2 pi. Or I could distribute that negative and put negative 8 plus 2 pi. All right, the choice is yours. Part D is very similar to Part C. In both cases, we have the integral from 3 to 7, and we have function g. The only difference is we have this 2 in here. So we've learned that we can evaluate the integral term by term. So this would be the same as the integral from 3 to 7 of 2 dx plus the integral from 3 to 7 of gx, well, g of x dx. The integral from 3 to 7 is what we just found. So we already know that this is going to be 2 pi minus 8. So I'm going to put plus 2 pi minus 8 right here. So we really just need to evaluate this. However, we know the integral of 2 is 2x. We just need to evaluate using the limits of integration, 3 to 7. This means we're going to evaluate at 7 and then subtract the value at 3. So we're going to do 2 times 7 minus 2 times 3. And we still got the plus 2 pi minus 8. But this is going to be 14 minus 6 plus 2 pi minus 8. 14 minus 6, so that's 8 plus 2 pi minus 8. The 8 and the minus 8 cancel each other out, and we are left with 2 pi. So that would be the final answer. For part E, we need to find the integral of g from 0 to 3. This shaded area would represent the integral of g from 0 to 3. The area above the x-axis is a positive area. The area below the x-axis is a negative area. Notice that the net area from 0 to 3 can be thought of as the sum of two separate areas. This can be thought of as the sum of the integral from 0 to 2 plus the integral from 2 to 3. In other words, it is this yellow positive area plus the blue negative area. Splitting it up this way will be useful because we already found this one on a previous problem. Back in part A, we worked out that the integral from 0 to 2 is 2.5. So we have 2.5 plus this blue area. This is a triangle, so we're going to do 1/2 base times height. The base is 1 and the height is 2. So 1/2, 1 times 2. Because this is a negative area, it's below the x-axis, then this will be negative. And I don't like to put plus a negative, so I'm just going to erase this and put a minus. So we have 2.5, and 1/2 of 2 is 1. So we have 2.5 minus 1, which equals 1.5. So that's the final answer. That is the integral of g from 0 to 3. One more. Let's do the integral of g from 1 to 3. This shaded area represents the integral of g from 1 to 3. Notice that the yellow area above the x-axis is positive, and this blue area below the x-axis is negative. So we can think of the integral from 1 to 3 as the sum of these two areas. We can do the integral from 1 to 2, and then add that to the integral from 2 to 3. So the yellow triangle plus the blue triangle. The yellow triangle is going to be 1/2 base times height, which is 1/2, 1 times 2. And then the blue triangle is also 1/2 base times height. So that's going to be 1/2, 1 times 2. But don't forget, because this blue triangle is a negative area, being below the x-axis, we're going to put a big old minus sign in front of this. And in fact, usually I will not put plus minus, I will just do the minus. So you really could have seen this at a glance, but I'm just going through the motions and showing my work. But you can see that the positive area and the negative area have the same size. So they are going to cancel each other out, which is why the answer is going to be 0, a net area of 0.